using some examples. And in the today's class, we are going to discuss what is the relativity of motion by using the what? Frame of reference. So in the today's class, we are going to discuss about what? The frame of reference. So as we know, relativity is nothing but it deals with the relation between the rest and motion of a particle. So rest is nothing but what? If a body doesn't change its position with respect to the time, that is called as rest of a particle. If a body changing its position with respect to the time, means we are calling it as what? Motion of a particle. So coming to the point for the frame of reference, so I am going to explain by using some example here. Suppose one tree is there on the surface of the earth. This is the tree which is there on the surface of the earth, and one person is standing on the what? Surface of the earth. Now according to this person, so let his name as A I will take. So according to the A person, the tree will not move, means it is at a what? Rest position. So according to the A person, the tree will be at the what? Rest position. And in the second case, as already we know, the earth rotates around the sun in an elliptical orbit. So always earth rotates around the sun in an what? Elliptical orbit. So now this tree is there on the earth. Let me take that position of a tree here. So starting it is at here. Now I will take another person who is there in the what? Space, and his name I will give it as B. According to the B person, at the starting time the tree is here, but an earth is rotating around the sun in an elliptical orbit. After a certain interval of time, the earth is coming here, means the tree position is also what? Goes on changing. Again, after a certain interval of time, the earth will come here, so the position of a tree will be what? Here. Means when the B observer observes the same tree, this tree only, at the starting time it is here, after a certain interval of time the position is changing, again after a certain interval of time the position will be here. Now if you observe these two cases, according to A person the tree position is at rest position, but the same object, means a tree, according to the B observer it is under the what? Motion, we can say. So whenever we are defining whether the particle is at a rest position or the particle is under a motion, with respect to what we are defining plays an important role here. With respect to A, it is at rest, and with respect to B, it is under the motion. So with respect to some reference, what we are defining, it plays an important role, and that is nothing but what? The frame of reference. That is what? The frame of reference. See, rest or motion we can define by using the what? The position of an object. Position doesn't change, rest. Position, if it is changing, it is what? Motion. So to define this position, certain system we will use to define any motion position of an object, and that system is called as what? Frame of reference. Now coming to the point. So I will take one room here. This is what? Nothing but one room, and one object is there in the room. Starting it is at a rest position. Let me take it as a rest position. So when it is inside the room, I want to define the position of this object. Then what can I use? So already you studied speed is equal to distance divided by time. So by using that ratio we will find the speed, and velocity is equal to displacement divided by time. Acceleration is equal to change in velocity divided by time. So by using that we are finding speed, we are calculating velocity and the acceleration. In the same way, I want to know what is the position of an object. I want to define the position of an object. So what will be the dot point? So coming to that point, suppose in one room, one object is here. Is it the object? And I want to define the position, where it is. Is it nearer to this wall or where it is nearer to this wall? Like that. I want to find that position. So to find the position of any object, some rules we will follow. and that rules are nothing but one system we will take. That system is one is x-axis, y-axis and the z-axis. The system contains x-axis, y-axis and the z-axis. 3 coordinate axes will be there. Now, as this object is under the room, now we will find at how much distance it is there from the x-axis. So that is the first coordinate x. How much distance it is there, whether it is 1 centimeter, 2 centimeter, at how much distance is there from the x-axis, that is the x position, comma, at the same time at how much distance it is there for a y-axis, so that is y coordinate, at the same time it is how much distance is there from the z-axis, that is z coordinate. So by using like these 3 coordinates x, y, z, we can define the position of this object, isn't it? We can define the position of the object. If it is there at how much distance from the x-axis, how much distance from the y-axis and how much distance from the z-axis. So if you denote that distance, that representing the position of the object. Now, how to get whether it is rest or motion? So here I will take time and here I will take position coordinates, isn't it? At the 0 second, what is the position coordinates? X, y, z. After 1 second, again I will measure the position coordinates. Again we will get x, y, z only. Again after a certain time, the position coordinates remain same only. Means with respect to the time, if you observe the position coordinates, it remains constant only. That's why we can say the object is at a rest position. So is it the best way to define the position of any object? Okay. So to define the position of any object, we are using 3 coordinates here, x, y and z. Now whether it is a motion, how to define? Suppose at a 0 second the body is here, the object is here. After a certain interval of time, the body is coming to this position, the object is coming to this position. See, when it will come to here, of course the x distance increases here. At the same time, the y distance also increases. At the same time, the z distance also what increases. So now coordinates position will be what? Changing. The factors are changing. So now starting x, y, z. So can I take it as x1, y1 and z1, isn't it? So at the 0 second, x, y, z it is. But at the 1 second, its coordinates are x1, y1 and z1. Again, if it is moving again, then what will happen? Again the coordinates will change. So from this, we can observe that how the time will be running, the coordinates are also changing. Means definitely we can tell that the body is under motion. So like that, whether the body is at rest or motion, we will come to know by the what? Position of a body, and the position we will define by using what? These 3 coordinate system, and that system is called as what? The frame of reference. Means can we define a frame of reference is nothing but it is a system which defines the position of an object by using how many coordinates? It may be 2 or 3. Sometimes 2-dimensional space is enough and sometimes 3 coordinates are enough. The difference is what? Suppose any body is moving in a plane, means only the body is changing according to x-axis and y-axis. Their z-axis will not come. The same body when it is in a space, so when it is moving along x-axis also it is changing, along y-axis also it is changing, at the same time along the z-axis also it is changing. So any out of the 2 or 3-dimensional space, we are defining the what? The position of an object. So that system is called as what? Frame of reference. So frame of reference is nothing but what? A system of coordinate axis. This is the coordinate axis, x, y and z. This is the system, isn't it? So a system of coordinate axis which defines the position of a object by using 2 or 3-dimensional space. So this is what? The frame of reference. And coming to the point, To define the position, we are using a coordinate system there. So actually, three coordinate systems are there. One is Cartesian coordinate system. The first one is Cartesian coordinate system. Second one is cylindrical coordinate system, and third one is nothing but spherical coordinate system. First one is a Cartesian coordinate system, second one is a cylindrical coordinate system, and the third one is nothing but what? Spherical coordinate system. In Cartesian coordinate system, what will happen? The three-dimensional space, we will take it as a x, y, z. Means Cartesian coordinate system is used to define the position of an object by using three-dimensional space, by using three coordinates that are nothing but x, y, and z. Again, cylindrical coordinate system is also used to find the what? Position of a particle only by using the three coordinates, and that three coordinates are r, theta, z. R is the displacement vector there, and theta is the angle, how much it is making, and z is the distance with respect to z axis. And when we come for the spherical coordinate system, here also three coordinates we will use to find the what? Position of object, and that three are p, theta, phi. So by using these three, we will use the what? Spherical coordinate system. And for our theory of relativity, we are using one simple and most familiar coordinate system, which is nothing but Cartesian coordinate system. Which is nothing but what? Cartesian coordinate system. So now I am explaining a frame of reference again by using one example. So another example I will take to explain about frame of reference. Say, suppose this is the road. On the road, one car is moving. This is the car which is moving on the road and which contains one flag. This is the flag, and one person is sitting in this car. So he is the first person. And as car is moving, after a certain interval of time, it reaches to this position. It is reaching to this position. So again a flag will be there and a person will be sitting in the car. Same. And now another person I will take who is there outside the road. He is outside the road and he is observing the same car and the flag also. Now here we are using two frame of reference. One is this one. This person is acting as a first frame of reference, and the person who is there outside the road, he is acting as a second frame of reference. So two frame of reference is there. Now as he is using as a first frame of reference, he should contain three coordinate axes here, x, y, z. So by using these three coordinate axes, he will find the position of the flag. First he is finding the position of the flag, and that position is x, y, z. He denoted how much? X, y, z. And at the same time, when car is here, when flag is here, the second person is also observing the flag and he also defines the position of the object. And according to him, when he is acting as a second frame of reference, the coordinates will change there definitely, and that coordinates are x1, y1, z1. This is what the first case. Now, when car will be moving and it reaches to this position, so again same two frame of references are there. This is the first and this is the second, and the flag is there. Now again he will define the position of a flag by using the first frame of reference. So in the first case what it is? X, y, z. And when it will move and reaches to this position, at that time whether the position of a flag changes according to the first person or not. Yeah, it will be what? Same for here also. because both are under the motion with the what? Same velocity. That's why again he got the same coordinates. So that is what? X comma y comma z only. But at the same time, according to the second person, second frame of reference, what he will get? Whether he will get the coordinates are x1, y1, z1? No, because according to this frame, starting it is here, but when it is moving, it reaches to here. So according to him, the position is changing. The position of a flag is changing. So now he will get another coordinates, that is x2 comma y2 comma z2, isn't it? So now completely you can understand the frame of reference. See how object will be changing, like that the frame of reference is also changing. Or you can say according to the frame of reference, the position of the object will be what? Changing. See, according to this frame of reference, the position of the object, whether at here or here, it is the same only, x, y, z only, because the reason is both are under the what? Motion with the same velocity. But now coming to the second frame of reference, the whatever the position of a flag is there, it is changing because it is moving with a certain velocity. So according to this second frame of reference, starting its coordinates are x1, y1, z1, but when it reaches to the second end, the coordinate becomes what? x2, y2, z2. So like that, in day-to-day life, many examples we will get to find the what? Frame of reference. So another example I will give. Suppose one observer is standing on the surface of the earth and one aeroplane is there in the sky as it is under the motion. So the aeroplane is moving in the what? Sky. So when it is moving, another person is sitting in the aeroplane. Now one bird is flying in the sky. So whatever the bird is flying in the sky, both the observers are seeing the same bird. So according to the first person who is standing on the surface of the earth, he will get the position of the object at something, but at the same time the person who is there inside the what? Aeroplane, the position is what? Different, isn't it? So as he is nearer to the bird, his position is different. As he is far away from the bird, his position is different, isn't it? So from this means it is the conclusion that how the frame of reference is changing, like that the position of an object is also what? Goes on changing and changing. This is what the thing. And now coming to the point, whatever the motion we are talking here, whether that motion is absolute or relative, that will be the thing. Absolute means constant. Whether the motion what we are talking is constant or it is relative. So the thing is, as we know, whatever the objects is there on the surface of earth are all under the motion because the earth is rotating around the sun, isn't it? So when earth is rotating around the sun means the object whoever is there on the surface of the earth, that are also under the motion. So in one simple way I can tell this. No any object is there in the universe such that they are completely at the rest position. They will not be at the rest position at all the time. All the objects are little bit what? Moving only. So no any such object is there which is completely at the what? Rest position. So from this we can say the motion is not a absolute thing. It is not a constant thing, but it is what? Motion is always the relative term. The motion is always what? Relative, because whatever the objects are there in the universe, that all are under little bit with the, they are all are moving with what? Certain velocity only. As earth mass is heavy and as it is moving with a lower speed, we cannot experience the change in the position, isn't it? So that's why we are feeling that we are at the rest position. But as earth is rotating, we are also what? Moving only. At every second of the time, we are changing our position only, isn't it? So that's why we can tell definitely the motion is always a what? Relative term. It is not an absolute quantity. So three things we studied. One is frame of reference, second Cartesian coordinate system, and about the motion. Frame of reference is nothing but a system of coordinate axes which defines the position of a particle by using what? Three coordinate axes. Then Cartesian coordinate system is nothing but what? Which specifies the position of an object by using three axes x, y, z, which are perpendicular to each other. All are perpendicular to what? Each other. And coming to the motion, motion is always a what? Relative term. So this you should remember. And in the next class, I am going to discuss about the types of the frame of reference. So which is most important for other derivation of this chapter. So frame of reference, if you understand, then only you can understand the types of the frame of reference. So remember the frame of reference with a certain example. So just remember that with respect to the object, we can choose the what? Frame of reference. So how object changing its position, the frame of reference also we can what? Goes on changing. So this is what the thing.